In previous lecture, we learned about the number system. Reason we learned about number system is because every piece of data or information in computers is converted to numbers before it takes the form of electrical signals. In this lecture, we will learn how textual data, graphics, videos, and audios are given the form of numbers in computers. Before going towards representation techniques, first we must be clear about the terms data and information. Data is basic values or facts. It doesn't have any structure and lacks context. You can say that it is unprocessed or disorganized information. Information is data that has been organized and or processed in a way that is useful in solving some kind of problem. We will also learn how data and information is compressed due to storage limitations in computers. First computers were not multimedia devices. They could only process text data. So only English alphabet letters, numbers, and symbols needed representation. Today computers are multimedia devices. These computers can process data in form of numbers, text, audio, graphics, images, and video format. All of these types of data need to be represented in bits 0 and 1 before being converted to electrical signals in a computer circuitry. In real world, there are no fixed values for data representation. If change in value of data are continuous and infinite, data is called analog, like an electrical signal in stereo or human voice. Computers use fixed number of values for data representation. All kinds of information is broken down to these fixed values or discrete elements. These discrete elements are assigned digits or numbers like 0 and 1. Assigning digits to discrete elements of any type of data is called digitization. Digits assigned are 0 and 1. As two sets of voltage are easier to work with, that's why 0 and 1 are or binary numbers are used. Other number systems can be used, but it would become complex and expensive to design devices that use more than two states of voltage or digits. Analog signal is represented with sine wave. A small degradation in analog signal causes information to lose instantly. Because all voltage levels represent some kind of information, a digital signal jumps between two extremes called high value and low value. If these values are assigned numbers 0 and 1, periodically digital signals can be relogged to regain its shapes. Hence, degraded digital signal is easier to recover than an analog signal, and loss of information or degradation can be avoided. In binary representation, there are only two digits 0 and 1 to represent information. If we were to represent two things, say black and white, 0 and 1 can be used. To represent more than two things, combination of 0 and 1 can be used. Two bits can represent four values 0, 0, 0, 1, 1, 0 and 1, 1. Three bits can represent eight values 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1. 4 bits can represent 16 values. 5 bits can represent 32 values. In general, n bits can represent 2 power n values. So 8 bit can represent 2 power 8 is equal to 256 values. Number of bits used depends on the number of things you want to represent. For example, to represent 7 colors, you will need 3 bits. To represent 24 colors, you will need 5 bits. Since 2 power 4 is equal to 16, and 4 bits are not enough for 24 things. And 2 power 5 is equal to 32 bits, and so 5 bits are enough to represent 24 things, but some combinations will be unused when we use 5 bits. Computer architectures are designed to address data and sizes of powers of 2 as well, such as 8-bit computers, 16-bit computers, 32-bit computers, and 64-bit computers. So techniques we are using to store and represent data in computer memory must take into account the architecture of the machine as well.